AP Cam, here's this is on molarity of ions. It's page 9 of your notes, question 15 only. Okay, so we did some molarity. Remember, molarity is the moles of solute per liter of solution. Moles of solute per liter of solution. So if you have 1 mole of barium nitrate dissolved in 1 liter of solution, okay, the molarity of the solution, it's 1 mole of this compound per liter. So the molarity of the solution would be 1 mole per liter. So the molarity of barium nitrate equals 1 molar. In other words, there's 1 mole of barium nitrate and 1 mole in 1 liter of solution. If we use half that solution, it'd be a half mole of barium nitrate. Now, since we typically use net ionic equations, we typically want to know the molarity of each ion in solution. So if we think about barium nitrate in solution, it's going to produce a mole of barium ions, 1 mole of them, and it's going to produce 2 moles of nitrate ions. So we want to know the concentration of each of those ions individually. Now, every mole of this compound makes a mole of those, so it'd be a mole of barium ions in 1 liter solution. So this concentration would be 1 molar. And there would be 2 moles of nitrate ions in that liter solution. So this concentration would be 2 molar. So the overall concentration of solution is barium nitrate is 1 molar. Barium ions concentration is 1 molar, but nitrate ion concentration is 2 molar. So here, if we have this concentration of Al2SO4, let's think about the concentration of each ion. So that's the concentration of the whole compound. Well, every mole of that compound produces 2 moles of aluminum ions and 3 moles of sulfate ions. So we got to take this molarity times 2 to get the concentration of aluminum ions, and that molarity times 3 to get the concentration of sulfate ions. So our aluminum ion concentration, this times 2 would be 0.0476 molar. That times 3 would be 0.0714 molar. So even though the whole compound is only this molarity, the aluminum ion concentration is double that, sulfate ion concentration is triple that. All right. You have the concentration in moles per liter, so in molarity, of each ion in 1.25 molar Na3PO4. Well, the whole solution is that many moles per liter, so that means the sodium ions would be that times 3.75 molar. So 1.25 times 3 would be 3.75 molar, would be the concentration of Na plus ions. One thing I forgot to tell you, whenever I write concentration of something, you put it in brackets. That means concentration of in molarity. Those brackets mean concentration of. You're going to see that lots and lots of times this year. If the whole thing is 1.25 molar, there's only 1 mole of PO4 negative 3 ions, so 1.25 molar would be the concentration of phosphate ions. All right, those are fairly easy questions, hopefully. This one's a little bit different. How many moles of potassium ions, not the molarity of it, wants to know actual moles, are in 2 liters of 0.5 molar potassium phosphate? Well, potassium phosphate is K3PO4. So when that dissolves, it produces 3 moles of potassium ions and 1 mole of PO4 negative 3 ions. So we start with 2 liters. I never start with molarity. The molarity is 0.5 moles per liter. That means that every liter, remember that's your molarity, contains 0.5 moles of potassium phosphate of the whole compound. So if we stop right there, if we multiply those, that would tell us how many moles of potassium phosphate. We want to know moles of just potassium ions. Moles of just potassium ions. So now I'm going to say that for every mole of K3PO4 that dissolves, there are 3 moles of potassium ions. Every mole of this compound that dissolves produces 3 moles of potassium ions. So 2 times 0.5 would be 1 times 3 is 3. Your answer would be 3 moles of potassium ions. 3 moles of K plus ions, 3 moles. That's not the molarity. It's not saying how many moles there are per liter. That's how many moles would be in 2 liters of that concentrated solution. One more. You have 25 grams of calcium chloride. What is the chloride ion in this much solution? So not in a full liter. What is the chloride ion molarity? So we want to know the concentration of Cl negative ions in molarity. In other words, we need to know moles of Cl negative ions per 1 liter of solution. So I know how many moles of Cl negative ions are there. So we got to figure out how many moles there are of Cl negative ions and divide it by our liter solution to get into 1 liter solution. So I'm going to erase that. So we're going to say, okay, we have 25 grams of calcium chloride, CaCl2. Calcium chloride as a whole, not just chloride ions. Calcium chloride as a whole is 111 grams per mole. And I'm going to say that for every mole of calcium chloride, there's 2 moles of chlorine ions. For every mole of calcium chloride that dissolves in water produces 2 moles of Cl negative ions. So that cancels. That cancels. We're left with moles of chloride ions. And then we can get an answer and then divide, but we need to divide that by our liters. So I'm just going to put divided by 0.65 liters. There's nothing on top of that, which is a little weird, but we wanted to get molarity of chloride ions. We wanted to know moles of chloride ions per liter. How many moles would be in a full liter? So multiply across top, divided by the bottom. It is about 0.7 molar is the concentration of chloride ions. All right, we'll do some more of those